Hello wonderful person, this is Anton, and in this video we're going to be talking about planets that form from interstellar gas, and more specifically about the concept of baby planets. Basically, how do planets form? What exactly happens between them being a gas and them turning into these beautiful balls of matter? And the thing is, we actually still don't truly understand what exactly happens, but we're getting a little bit closer to it. And in this video we're going to discuss two specific discoveries coming from nearby star systems where we finally got to witness the formation of actual planets from the so-called protoplanetary disk. Let's talk about this, and welcome to What the Math. To date, we have quite a lot of different observations from various star systems near us, where we got to observe, well, basically these really young star systems that are less than 10 million years old, where planets seem to be forming right now. But the thing is, even when we zoom into them and try to really see what happens to these planets, it's kind of difficult to see because of the distances involved. And so as of today, our understanding about planetary formation is kind of as follows. It starts with the interstellar dust cloud that slowly starts coalescing into a larger and larger object, and this object eventually starts forming these so-called arms, basically dust cloud arms that eventually start forming into planets. Now, in between this and the actual planetary formation, we still have a lot of questions to answer. We basically don't really know how all of this really occurs. In other words, we're still trying to understand the actual mechanism of what's happening inside the protoplanetary disk and what happens to these planets in order for them to grow so effectively. Pretty much most of the planetary models today kind of have this as a summary. The protoplanetary disk eventually slowly forms into planets, and the actual dust in between disappears with time. But in order for us to understand how planets grow, we actually have to try to zoom into these baby planets, or basically the very early star systems, and try to see how they actually consume matter and what effects cause them to grow larger and larger, specifically planets like Jupiter and Saturn. And so there are two particular systems that scientists have been investigating, one very well known and one very recently discovered and confirmed to have an actual planet on the inside. The most recent discovery was actually from this system right here, known as AB Auriga. This has been known to us to most likely possess some sort of a planet or possibly a brown dwarf in the middle, simply because of the shapes we've been observing in this particular star system. But because it's about 520 light years away from us, it's still a little bit difficult to see what's going on here. And so for this study, some of the most advanced telescopes from the so-called European Southern Observatory were used along with some of the most recently updated hardware to essentially try to zoom in and see what's going on the inside. And this time we were definitively able to see an actual planet growing in the middle. Now, it might not really seem to be visible here at first glance, but using the technique known as adaptive optics, the scientists behind this paper were able to eliminate the luminosity of the actual disk by essentially subtracting it from the total picture in order to see a definitive sign of an actual planet growing very close to the star itself. And what's really important to understand here is that there's actually this unusual spiral that forms in the middle of this star system, sort of reminiscent to what we have in galaxies as well. And this right here in the middle, that's the planet itself, with these spirals here creating a kind of a disturbance in the disk in the form of the wave that disturbs the disk enough for all of this mass to suddenly start coming into the planet afterwards. And as you can see here, the wave gets shaped into a kind of a spiral, but the spiral itself sort of feeds the planet, allowing it to grow larger and larger, with the average distance right here being equivalent to about 30 astronomical units, or about the same distance as Neptune is from the Sun, which is actually much closer, actually about twice as close as the previous assumption of about 60 to 80 astronomical units, with scientists previously thinking that the planet was somewhere right here or even farther away, mostly because we didn't really understand how all of this works just yet, and actually we still sort of don't. But at least now it's more clear to us that this is exactly where the planet is, and there's almost no doubt that this is going to be some sort of a large Jupiter-like object, possibly a few masses of Jupiter in mass. And the two spirals here, with one going outwards of the planet's orbit and one going into the planet's orbit, allow the gas from the planetary disk to essentially get sucked into the planet, and through this interaction the planet grows larger and larger in size. But what exactly causes for these spirals to appear, and also why exactly these spirals are necessary for planets to grow, is still a bit of a mystery to us. We're still not entirely sure how all of this starts and why these spirals are necessary for planets to become like they are. But there's another much more interesting system that we've studied for much longer, known as PDS-70. This system, as you can see, has two definitive planets. They were very recently confirmed once again, and this particular study even goes as far as establishing their approximate mass, their distance from the star, and also the amount of mass that these two planets are growing by, basically allowing us to calculate how fast the planets usually grow. The original images using older technology didn't really allow us to see much, but there were already speculations approximately 10 years ago that there were actual planets being developed here. And about a year ago, a study came out announcing that there are definitely two planets in the system, although they needed to be confirmed with further, much more detailed observations. And at a distance of about 370 light years away from us, it is once again not very easy. But the scientists behind this particular paper were able to confirm that these two planets do seem to exist, and the star itself is about 82% the mass of our Sun, it's around 10 million years old, and has two planets located at the same distance as Uranus and Neptune, about 20 astronomical units and about 34 astronomical units. The closest planet is a relatively cold gas giant world, possibly about 3 to maybe 4 masses of Jupiter, and is located at the same distance as Uranus, whereas its partner is even farther away, but is a little bit less massive. Its mass is possibly about 2 masses of Jupiter. Both planets are going to be super cold by the time they're finished being created, but right now their temperatures are actually not very cold. The average temperature of gas here is about 1000 degrees Celsius, mostly due to all of the interaction going on in the middle of the star system. And I was also very curious to find out, so how fast do these planets grow? Especially since the star system is about 10 million years old, it means that these stars have been eating a lot of mass for the past 10 million years. And the scientists behind both papers suggest that the average absorption rate of mass, basically how fast the planets are eating, is actually surprisingly low. It's equivalent to basically eating the mass of our own moon, the one that's orbiting our planet of course, every 100 years. That kind of seems pretty slow, doesn't it? But that's sort of what the studies suggest, and it does seem to indicate that the actual planetary growth is a really slow process. Although this still doesn't really help us explain what exactly happens to these protoplanetary disks in order to start this formation, and also why these unusual formations, these unusual arms, form to begin with. And most importantly, I guess the question is, since galaxies have these arms as well, is something really unusual being grown in the middle of these galactic arms as well? And if so, what exactly is it and how does it affect the rest of our galaxy? This is of course a very wild speculation, but because we've been observing these in the middle of star systems, it's sort of worth investigating this in the middle of galaxies as well. But anyway, until we learn more about the formation of star systems and of course baby stars, and once we learn more about the galactic arms and the unusual arms in the middle of star systems, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and come back tomorrow to learn something you may have not known before. Maybe support this channel on Patreon because it does help me quite a lot, and maybe support this channel by buying the Wonderful Person t-shirt that you can find in the description below. I'll see you tomorrow, space out, and as always, bye bye.